Passing web application files first, just briefly make a case for them, and then I'm going to switch to ModSecurity, and then finally, in what I think would be the most interesting part, I'm going to give a few real life examples of how ModSecurity is used. So that part of the talk is kind of open-ended because there are too many slides for a 45-minute slot. So we'll see how much we can squeeze in. You already know about me. The important things, I wrote Apache Security, which I think is of use to anyone running Apache, and I'm better known these days for working on ModSecurity, of course. I'm also involved with Owasp and the Web Application Security Consortium. And the reason we need web application firewalls is basically we're in a big mess. As you very well know, most websites and web applications out there are terribly insecure, which is no wonder because we're using a protocol that was designed to do something completely else. And I think this is the first example in our history that we had an ecosystem, actually, of components, where each component is developed by a different vendor, a different entity, and all these components, be it browsers, databases, browser plugins, and so on and so forth, they're trying to work with one another, and because there isn't a single kind of coherent view or strategy or architecture or anything of the sort, we're experiencing the problems that we're experiencing today. So we've tried to make it better. I think we've realized this sometimes around year 2000, and the three major approaches to making things better is, of course, developer education. We have design and code reviews, and then, of course, we have pen testing. And, of course, today, I'm going to talk about the fourth one, which is about web application firewalls. Now, the thing is that there's a lot of controversy about web application firewalls, especially in this year, because of the PCI requirement that would basically endorsed web application firewalls in a big way. And people often focus on the fact that it's much better to fix a problem in the code than to deploy a web application firewall to fix it, and that's absolutely right. And however, while there's some overlap between web application firewalls and every other measure that you can use to increase the security of your web applications, there's actually a lot of there's a great deal of issues that cannot be covered with any other tools. If you take a perfect web application that has no security issues whatsoever, that's fine, but if you put it in production, you're going to have configuration issues. And if you look at the real life problems, actually, a great deal of them come from configuration problems. And then there's also another group of problems that are simple operational issues, such as the rate of access. The real issue that web application firewalls need to solve is that of the lack of visibility. Lack of visibility is one of my reasons why I built ModSecurity in the first place. If you, in a typical web application, you have no idea what's happening. The way web servers do logging, that's completely inadequate to give you any idea kind of if you're being attacked, why, how, and so on and so forth. So this is where I'm coming from. This is where I think web application firewalls should be coming from. Of course, the additional, and I'll be talking about why web application firewalls are necessary. In a way, they're complementary to IDS and IPS systems, in that the IDS systems are designed to work on network level. Well, web application firewalls are tools of similar nature, but they're designed to work on the HTTP level. This is a slide I've had in my presentations for many years now. But the biggest problem is with the IDS tools is they're designed to work to apply simple operations against a lot of traffic, and to really counter the HTTP problems and problems with web applications, you really have to dig deep. You have to dig deep into parsing, you have to deep into counter evasion, and all sorts of other problems. Of course, web application firewalls have long had the problem with identity. in that no one really knows what they are and what these tools do. And this is one of my favorite slides, where at least 23, I think, different names that were used to refer to products that we now know as web application firewalls. So over the years, we've just the one name stuck. And if you really think about it, the name itself is not adequate at all, because it implies an exclusively access control device, which is what firewalls are. However, web application firewalls are much more. If you think about it, on the network level, we have routers, we have switches, we have firewalls, we have all these IDSs, and all these uses are actually available within the same device on the HTTP level. So here I have 4 different use case scenarios for web application firewalls, and the first is, in my opinion, is the most important one, is auditing and monitoring device. So this is what I mentioned before, is something that actually gives you visibility, and if you don't have visibility, then you don't have any control. So that's why I think that's very important. So it's a product that you put in. It can be a plugin, it can be a box, it doesn't really matter. You put it in, and it suddenly starts seeing things. And because it's going to be smart and understands HTTP very well, it's going to be decoding things, it's going to be parsing things for you, it's going to make your life much, much easier by providing you access to to the data that's being exchanged. And from this use case, you actually are going to discover what's happening, and then you get to choose what you're going to do about it. So some people choose to do nothing and then perhaps observe attacks as they're happening. Some people choose to do blocking. And in fact, virtual patching, which would fall under access control, is a very good use case for web application firewalls. If you have a vulnerable application where you've just discovered the problem, to fix that application in the code, that's going to take a long while. How long, it really depends on the organization, but chances are it's going to be measured in weeks, maybe even months. With a web application firewall in place, you could realistically do it in 15 minutes, assuming that the product has already been configured. So this reduces the window of opportunity that's available to the attacker significantly, and allows the developers to actually focus on solving the real problem and not just scrambling up a patch quickly. Of course, there are other use cases, such as layer 7 routers and switches. This is only if you deploy web application firewalls as reverse proxies. And there's a catch-all category, which I call web application hardening tool, which is just a bunch of other functionality that cannot be categorized, but each part actually helps improve security. So I personally think that the term is overloaded. We should either stick to switch to using different terms, or use something that doesn't have the word firewall in it, such as web intrusion detection system, which I find much more palatable, or something around HTTP security monitoring. So if you're interested in web application firewalls and you considering deploying them, I've started a project some time ago, which is called Web Application Firewall Evaluation Criteria, and it's a technical document. Basically has 20-odd pages, tells you all the questions that you need to ask the vendors, and then you can use those questions and answers to figure out which product to choose. I do invite you to join the project. But also tomorrow, and I think in this very room at 8 o'clock, there's going to be another talk dedicated to web application firewalls. And it's about best uses, that talk is more oriented toward discussing organizational issues and how to judge whether a web application firewall is the right approach to use with a particular application. So it's complementary to the WAF project. Anyway, so that's kind of a brief introduction to web application firewalls and to the problem domain. ModSecurity is the web application firewall I started to write in 2002, and by now it's the most widely deployed web application firewall. And as far as I know, it's the only open source web application firewall. And while I'd like to think that the popularity of ModSecurity is the result of its qualities, I'm guessing that it has more to do with the fact that it's free and just available out there. So the barrier to entry is pretty low. On the other hand, it doesn't have a GUI, and this is by design, because I've always thought that people should really know how they're using their tools. And if you get a product that's just a black box, that you don't really know what you're doing, you don't really know if you're using your tool to address the issues that you have in your network. So I think that not having a GUI for a product is a good thing, because it forces people to think, it forces people to understand what they're doing, and in the end that results with a better security overall. So back in 2002, I was running a software development team, and part of what we did is we used to produce web-based software. And I sort of had trouble sleeping at night, because I was ultimately responsible for the quality, and I knew that we didn't have enough time to dedicate to solving the security issues in our software. And this is because of the business pressure to deliver a feature, not software. And I'm sure that you will find this in many organizations, if not all. In fact, I think you will be hard-pressed to find organizations that's focused on security and where features come second. Or anyway, sometimes in 2004, I started a business around ModSecurity, and it was eventually acquired by Bridge Security, the company I work for. And we continue to treat ModSecurity as an open source project, and it continues to grow. In fact, quite a few resources have been dedicated, additional resources have been dedicated to it over the years. The way it works, you can deploy it in two modes. You can take your existing Apache web server, and you can just plug in ModSecurity into it. And we're looking into expanding the web service we work with, but at the moment it's only Apache. And the other approach is, of course, to deploy it as a network gateway. What you do is you take the Apache web server, you install it as a reverse proxy, and you add more security to it. And you get your open source web application firewall that works as a gateway, which is a really handy thing and quite useful. So here are the most important things you need to know about ModSecurity. This tool was written as an engine. It was written to empower our users and to give them tools and features that they would allow them to look at HTTP traffic, basically what I like to call slice it and dice it. So it doesn't, for quite a few years, ModSecurity didn't come with any rules. And it certainly today doesn't do anything implicitly. Unless you tell it to do something, it's not going to do anything. It tries to be very passive. As much as we can. So if it spots problems, it's not going to block anything. Instead, it's going to raise flags, internal flags, which you can then evaluate, and then you can decide what you want to do. So the overall, the idea is that you are in control. And also, the most important part, of course, is that we are documenting everything we know about ModSecurity. So because ModSecurity, like any other tool, has its rough edges, you will find that our rough edges are documented. So what we aim for and strive for is transparency. And this is why I think ModSecurity is an important tool. And here you are, you've taken ModSecurity, you've plugged it in. Now the question is, what are you going to do, and how does ModSecurity work anyway? And at the moment we have 5 different phases which we call, that we work at, and in general you're going to be interested in only 2 of them. One is the request phase, where you basically evaluate a request and decide and look at it and try to figure out whether it's valid or not, whether there are any attacks in the request or not. And the second phase is the response phase, where you have full access to the response. We haven't yet. So basically, in both of these phases, we've received the full request, but we haven't passed it on to the web server. So it hasn't reached the backend application. In the other way, in the response phase, we have all this in the entire response, the headers and the response body, but we haven't passed it on to the user. So in both cases, there's the opportunity to analyze data and to block things should you decide to block. But of course, you don't have to, so you can do exactly what you want. However, because we want to allow you to decide exactly how you want to handle certain things, we have additional phases. One is the request headers, which basically we run just after request headers, and we allow you to configure how you want the request body to be processed. And the other is the response headers, which we invoke just after we receive response headers, but before we actually go and read the response body. The final phase is logging, and this is intended to allow you to decide whether you want to log the request or not. You see that logging is very important, and ModSecurity has extensive logging facilities. Now, what we're doing right now, by the way, the current stable version of ModSecurity 2.5, in version 3, we are adding another orthogonal feature, which is streaming data analysis, where we are going to be analyzing data as it comes in. So this is a separate feature, and this is actually what most IDSs would do anyway. This is where they start. So ModSecurity has kind of evolved the other way. We will evolve from a discrete analysis of data. Now we're going to be covering the streaming as well. The advantages and disadvantages to both. Streaming is interesting because it allows you to not buffer. And in some situations, you wouldn't really want to buffer depending on the application and so on. So I mentioned transaction logging, and one really nice thing about ModSecurity is it actually allows you to decide exactly what you want to log and what not to log. So for each transaction, you can have rules in the configuration that can evaluate and look at it and say, I want to log this or I don't want to log it. And even nicer, within the transaction itself, you can choose which parts are of interest. So if you want to log a transaction that's it's a large download, you don't really have to log, it could be an image. You don't really want to log the part that's the image. You just want to log the request and maybe the response headers, but not the image itself. So ModSecurity allows these things. And what's also very important is we allow for sanitization to take place. So if you have sensitive data there, you don't want that to be logged. So we remove that data, provided there are rules for that. We remove the sensitive data before logging. And that's how ModSecurity avoids being a liability. And then finally, we have a tool that actually supports multiple ModSecurity sensors, takes all these alerts that we've logged, and transmits them to a central location. As you'll see later, we also have a product, a free product that you can use to review this data. So now, you know about these phases, and you may be wondering what the rule language looks like. The rule language, ModSecurity lives within Apache, and the rule language we have is sort of evolved within the constraints of the Apache configuration syntax. And it's designed basically to make the most common things very easy to do. And it's also designed to make the complex things possible. And you'll see how this works later on. But basically, here's what you will do in your rules. ModSecurity will pre-parse everything. It will give you access to the data. Then you can transform the data in many ways to counter evasion or to just extract some pieces of information. And then you look at it, and then you decide what you want to do with it. And furthermore, you can combine rules to make complex logic. And I'll have some examples here. A rule simply has three important bits, which is the targets, which is those are the places where you want to look at. Operators, how you want to look at them. And then you have a list of actions that you can apply once you decide that there's a match of some sort. And you can see the first example. In the first example, we are looking at two different places of a transaction. The args parameter that's actually looking at all request parameters that have been received. And then we're also looking at all request headers. And then we'll be looking for a pattern, regular expression pattern, script, open bracket script. This is a very simple signature, if you will. And on the second line there, you can see some metadata. We've given an ID to the rule. We have a custom message, which is a cross-site scripting attack. We've configured severity. And we've chosen to deny, to block a request that has the open bracket script anywhere in the parameters or the request headers. And we've chosen to deny the request with status 404. So this is just scratching the surface of what's possible with ModSecurity. In the second example, we have two rules that are actually chained. In our terminology, chaining two rules creates a more complex logic. And then in the second rule, we're looking at just one very specific parameter. In this case, that's the parameter username. And then we're checking that username against the string admin. So what we're looking is a script that has the admin username. And if that matches, we're also going to check the remote address from which the request is coming from. And this rule is going to match if the IP address of the user is not 192.168.1.1. So the idea is that you would install this on a login script where the administrator is logging, and that you are going to warn or do something else for all logging attempts that are not coming from this specific internal IP address. So this is a sort of kind of additional security feature. So what makes ModSecurity easy to use is that we have 78 variables that you can use, and we have pretty much a variable for every single thing that you have in a request or in a response. So the only thing you need to do is look at the table, see what variable you're interested in, and write it in a rule. And then the second thing you need to do is choose how you want to process this data. And that's, for that you use operators, and we have a bunch of operators. Most people use regular expressions, but there's a bunch of others. We have 22. So we have regular expressions. We have parallel matching, which is quite efficient. Parallel matching is where you have a bunch of strings, a bunch of patterns that you match all at once. So with regular expressions, you match one regular expression pattern against a piece of data. With parallel matching, you can have 10,000 patterns all matched at once with the same piece of data, which speeds up matching tremendously. And there, of course, we have numerical parameters. One of the things I haven't mentioned is we have all these. ModSecurity is an old project. It's been 6 years now, and we've accumulated features over the years. So there are quite a few really cool things that you could do. And one of the things that we do is actually we process XML. So if you have XML going through your application, you can parse it, you can validate it against a DTD, you can validate it against a schema, and you can actually use an XPath expression to look into any part of the XML payload, extract that, and then you use any other operator that we have to actually look into that and analyze it. And we have a bunch of other things, such as we can use a real-time blocking list. We have geo-IP lookups. We support, I think we're the only web application firewall that supports file inspection. So you can apply an antivirus. You can run a file that's being uploaded against an antivirus product and determine whether it's safe to upload or not, and so on. We even have a special operator that you validate credit card numbers, because you don't really, to reduce false positives, regular expressions are not enough. So we have additional logic to verify that a number is a valid credit card number. And finally, actions. Actions are also the equally powerful aspect of ModSecurity. We have 42 actions, which is quite a high number. And there are many categories. We can block. We can block in different ways. We can influence logging, so that we choose to log or not log Sanitise arguments. We have the internal state. ModSecurity has its internal parameters, which you can set. You can increment, you can decrement, and there's also support for anomaly scoring. You can tell ModSecurity to gradually reduce a value of a variable over time, and so on and so forth. So it's quite featureful in that sense. And we have persistent storage. By persistent storage, I mean that you can take a look at an IP address, and you can start tracking that one IP address and keep some information on it in your database. So you can have a counter, just as an example, that you increase every time something suspicious happens from that IP address. And I'll have examples to show how it's done. So, okay, this is the third part. We have roughly half an hour left, which is plenty to go through a bunch of nice examples. That's right, 15 minutes. we'll reserve the rest for questions. So here's just one example, ignoring static content. Unless you tell it otherwise, ModSecurity will inspect every single request that comes to your web server. But in many cases, you don't have a need. You don't want to inspect the static pages. So here's one way to tell ModSecurity to back off of the static files. Basically, this is the Apache configuration syntax, and you say everything that falls into a G folder, we just want to turn ModSecurity off completely, and that's how we gain in performance, because you just don't spend time inspecting something that's never going to be a problem for you. We have a different way to do the same thing, and this is a chained rule that consists of 3 different rules. Where in the first rule we look for a get or head request, if it's a get or head, and if the file name ends in JPEG, GIF, or PNG, and if there are no parameters in the transaction, we can skip that processing. We invoke a rule called an action called allow, which basically tells to ModSecurity to stop processing this particular transaction. So this is a handy way to increase performance of ModSecurity without actually having to go inside and look into where static pages actually are. Okay, virtual patching. I mentioned virtual patching is a very good use case, and this example shows you how easy it is to actually perform virtual patching. Let's suppose that we have isolated a vulnerability in the script called apps/script.php, and we want to basically lock this script down. We want to use a positive security model. A positive security model is where you only verify that all the inbound data is safe and is known to be good, and you're not trying to detect any attacks. You don't care. If the data is good, you pass it through. And this particular script is supposed to have only one parameter. So what we're doing here, in the first rule, we're checking the number of parameters for this script, and we allow only one. In the second rule, we're checking the names of all parameters to the script, and we allow only the name stat_id. And in the third rule, we are looking into the stat_id parameter and making sure that it's a number, actually, that it can contain only digits, anywhere from 1 to 3 digits. So this is a perfect example of a positive security model that works really well, because you just ensure that you only get this one parameter, and that the only thing that you get in the parameter is a number, and then you're safe. If someone attempts to perform an SQL injection here, it's going to have a really tough time, because it's not going to be able to use any of the characters apart from the digits. Whitelisting, that's also a frequent example, frequent requirement from users. Users want to simply exclude certain IP addresses from being analyzed, so we want to allow all requests for these IP addresses. And this is more an example of the richness of the ModSecurity rule language, because I'm giving you 3 different ways to do the same thing, just to showcase how ModSecurity works. In all 3 cases, we're examining the remote address variable, which not surprisingly contains the remote address. In the first case, we're using the string equality test. In the second, we're using begins with. And the third, we're actually using regular expression. So the first example will only allow one IP address. In the second example, because we're using the begins with operator, we actually allow the entire C class, which is the 254 addresses. So anything beginning with 192.168.254. And in the third case, it's a slightly more complex example with that we allow only 3 IP addresses. So only addresses ending in 1, 2, or 5 are allowed from the address range 192.168 and 254. So in a future version, we might even add another operator that will allow you to actually use proper network ranges to do things. And here's where it gets interesting. If you want to track activity per IP address, and this is what I mentioned, persistence, the first thing you need to do, you need to decide how you want to track it. In this case, we're going to create a key, which is created out of the remote address. So you see that we're using the init collection action, and we specify the key is going to be the remote address. So from this moment on, every new address that, new transaction that comes in with a new IP address, we basically create a small database where we use IP addresses as keys. And then after that, we can do things with it, with the state. And in the second example there, we created a variable which we call score, which we can increase or decrease depending on what happens with rules. And in the second example, you have we're checking the value of the variable score. If it's greater than 20, then we start to block. So this is something you can use sort of for anomaly type protection, where you increase a counter when you see attacks, and only once a counter reaches a threshold, you can block. And in the third example, you can see how when you have a rule that does something, you can increase the value of the IP.score score by 1. Moving on, this is equally interesting, is that we allow using rules. ModSecurity actually has a concept of application. Within the application, it understands sessions and it understands users. So what we do, all you need to do actually is tell it where the session ID is. In this example, we're looking at the cookie, and we have a PHP application that uses a PHP ses ID, cookie name to store session IDs. And what we do, we'll take the contents of that cookie and tell ModSecurity that it's a session ID. And after this rule is executed, again, you'll have persistent storage that's specific to this particular session. So not only you can choose what we had previously to track users by IP addresses, you can track them by sessions. And you can even, I don't think I have an example for this, you can even track users. Because if you have a rule to detect logging events where people are supplying their usernames, you can add that, and you can take the username and you can store it inside the session storage. And by doing that, you will have known for each request both the session ID and the user ID. Also, the nice thing is the information that you set about the session ID and the user ID will be recorded in the audit log. So in the GUI tool, you'll actually be able to list all requests coming from a single user, or just from a session. Okay. Who said that?
That's awesome.
I think so as well. So moving on, sanitizing data before logging. This is just an example. I told you it's possible. You can do it in many ways. You can do it by name if you know in advance what the parameter names are. In my case, this is password again, and old password. However, you can also have a rule that looks at all parameter names. And if you see the word password in any of the names, no matter which variation it is, we can sanitize it. Or we can sanitize based on content. I mentioned the verify CC operator before. Well, in the last example here, we look at all parameters, and we actually verify each parameter and try to see if it's a credit card number. And if it validates as a valid credit card number, we sanitize it. So you can have this sort of rule to help you. So that you don't have to do a lot of work to implement sanitization. Okay, one thing I really like about ModSecurity, and basically I like, in addition to everything I've said so far, what I like about ModSecurity is its flexibility. And I think we are the only web application firewall that actually allows you to take data, transform it in any way possible to counter evasion. And this is an example where you have 3 different attack payloads. The simple one, which is drop table, obviously it's an SQL injection. The second example is where evasion is used with a mixed case, and there's a white space between the 2 words, so that's going to be confusing some tools. And even in the third case, you have an SQL comment used as a separator between the 2 words. So with this sort of flexibility, and I'm just scratching the surface of what's possible when it comes to evasion, it's very difficult to write rules that will actually mean something that will actually catch attacks. So what we have in ModSecurity is a concept on transformations. We start with the original string, and then we have a pipeline of transformations that one added to another, and then operators only run after the transformation is complete. So to counter this particular evasion there for about SQL injection, I have the rule on the bottom that is still simple. It still looks for drop table. However, we applied 3 transformations before we do that. We convert everything to lowercase. We replace all SQL comments with white spaces, and we compress white space. So by doing this, we've normalized the input data so that we would match and perform meaningful matches. This is an example of using a geo-IP operator that would allow you to look up where the IP address is coming from. So if all your clients are coming from your own country, you can simply disallow everyone else to come in and attack your application. And here's when I mentioned that ModSecurity is flexible. Here it is. Example where we can actually decode what's available in the basic authentication request header. If you look at the basic authentication request header, it starts with the word basic, and there's some base 64 encoded stuff there. And then I found that in many applications, people actually have base 64 encoded stuff. Well, we have an operator that allows you, transformation function that allows you to decode it. So what we have in the rule on the bottom, we have the first rule that will take the request header, it is authorization header, and it will match a regular expression, and it will capture just the base 64-bit. So we have a regular expression capture. So in the second rule, we take just the base 64 bits, and then we decode it with our base 64 decode transformation function. And then we move on to the third one. Once you decode the base 64 part, inside you will see the username, then a colon, and then the password. And we basically make sure, well, this rule will match if the username is either admin, root, or backup, which is quite often used when people are trying to brute force detect the usernames in an application. So the fact that you can actually take a piece of data, then identify a smaller part, decode it, and transform it in many ways is what's making ModSecurity really interesting, especially this last part, just to make sure that you can do with ModSecurity, you can do anything that you want with ModSecurity. We've added a full scripting language into it. It's still a bit experimental. We're not sure what's going to, we want to see how users are going to use it. But you can actually have proper scripts that can interface with the engine. They can talk to the engine to say, okay, in this example, give me the values of those parameters, transform them in these ways before you give them to me, and then you can use the Lua programming, which is like a proper scripting language, to do anything that you want with it and analyze. So this is designed for that very specific use case where you have a peculiar application where you need to handle it and you don't have any other way. Because this is bound to be a bit slower than what you can expect from running your rules alone. And I'm going to end this presentation with, by describing to you the ecosystem that makes ModSecurity. Obviously, there's ModSecurity itself, but we have something that's called core rules. If you don't want to spend too much time configuring ModSecurity, you can take this package, and by the way, it's bundled with ModSecurity these days. It's a very nice optimized rule set that's designed to not have too many false positives. You can take these rules, run them, and just take the low-hanging fruit. So that's a very good way to start using it. By the way, ModSecurity can be deployed in detection-only mode. So the way that you're deploying it, initially you turn detection mode, enable detection-only mode, and then ModSecurity will not interfere with your transactions in any way. Once you're happy that you're not seeing false positives and it's not breaking anything, you can switch on to blocking if you wish. The second project is the ModSecurity Community Console. It's not an open source product, but it's a free one that supports up to 3 ModSecurity sensors, and you can actually collect alerts from these 3 sensors, and there's a nice GUI that allows you to look at all your alerts. You can look into them. It can actually produce reports, send you emails, and it basically provides the minimum that you really need to use ModSecurity comfortably in this way. About the one major function it's missing is control of ModSecurity sensors. That's not available, so you would still have to use it, configure ModSecurity by hand. ModProfiler is the latest addition to the community, to the family. It's an attempt, at the moment it's a research project that we are taking ModSecurity logs, so it's HTTP traffic, and we're automatically creating positive security models out of them, basically automatically locking down applications. I think this is really exciting because I think nowadays applications just are designed to allow every request that's coming in, and I think that's fundamentally wrong. They should only allow requests they are able to handle. ModProfiler will try to reverse that. REMO is a community project that actually is a visual tool that allows you to take your input logs and manually create a policy security model. So that's very handy. And finally, the project that we call Distributed Open Proxy Honeypots. Basically what we have a distributed network of reverse proxies, of open reverse proxies, and we are letting the bad guys go through them. But we have ModSecurity in all of them, and we have ModSecurity configured to log everything and send to a central logging host. So what we're really doing, we're spying on the bad guys attacking people using HTTP, and we are trying to learn from that, so we would write better rules. And that's the end of my presentation. There are a few more slides there about the roadmap, but that's about it. Do you have any questions? Go ahead.
Does ModSecurity get used for PCI compliance for the web application firewall?
Yes.
There's been no debate about it. That's okay.
It's absolutely fine. You can read the qualification if you wish. I found the PCI qualification very interesting because what it says that it's not the tool, it's how you use it. And by the way, ModSecurity is as capable, with the exclusion of learning, which ModSecurity doesn't have. ModSecurity is as capable or more capable than any other commercial web application firewall product. Of course, you don't have the GUI. So I would think about whether I will be deploying in my environment depending on what my circumstances are. Because you don't want to spend too much time on managing ModSecurity. But it's a very good product, and it does everything it needs to do.
Run on Apache 2?
Yes, it does. The latest version doesn't actually run on Apache 1. Sort of as a way of trying not helping anyone who's still using Apache 1, because I think that we are doing the community a disservice by continuing to run Apache 1, because developers have limited resources, developers of Apache 2 or Apache, and we should really be allowing them to continue to move on, essentially. So.
What kind of core rule sets updated?
Um,
what kind of updates are put into them? What kind of changes do you add?
At the moment, core rules are updated with ModSecurity releases, and we are basically, the types of changes we're doing is mostly addressing the false positives. And what we like to do is open them up so the community would collaborate and add the changes as well. What we're going to do, we're going to push for automated updates of core rules, so that we already have a tool that we've built, it's almost there, that you just run it, and it basically updates itself. So that would be really helpful to address sudden issues. I don't know, if vulnerability in Apache, for example, things like that, that's really handy.
Imagine a scenario where you have one ModSecurity installation, and then you have, say, 30 different web applications developed by different organizations, and just one system administrator, and everybody working in agile ways of releasing software every 3 weeks. There's an administrative challenge.
Yeah. Yes, it is. Yes, there is. Is it one ModSecurity instance or many ModSecurity instances? Because what you can do, you can have a single reverse proxy, protect all those 30 applications, and if there's a lack of, if there isn't enough time to properly address application security issues on this level, I think installing core rules and going with them is going to catch the low-hanging fruit and increase the security substantially. And then eventually, if there's will within the organization and additional resources are found, it can progress further. That's how I would solve it.
Take one more question.
Okay.
We'll take 2 questions. Quick question.
Okay, 2.
You mentioned security profile. I wasn't clear what a security profile was. The one project?
The ModProfiler, we basically, you've seen my virtual patch example where we log down exactly for each resource the name of parameters, the possible values. That's what ModProfiler does. Takes a look at your application, basically all your parameters, and tries to log down every single one of them. So it's the same work that you would do manually.
Database support for
For?
Pipeline.
There's a protocol, a communication protocol, and this actually goes into a database. So the free community console goes in, moves audit logs into a database. So it's a relational database that you can access. But the communication protocol between ModSecurity and any central logging sensor is open and well defined, and it's very easy to extend.
You mentioned mlog.
See, there's the component takes logs from one instance and submits them to the central. It's part of ModSecurity.
To any database, like what do you use?
We in our free tool product we use Apache Derby, which is a Java based database.
So JDBC.
JDBC works perfectly. Thank you very much.